Okay, so today we're going to talk about binomial distributions. I just collected the surveys from yesterday. Some of you still didn't do it, so turn those in as soon as possible. Okay. Our objective today is to find the binomial probabilities and use binomial distributions. So I had bell activity here, but for first hour, because you're the only class I didn't tell to work through number 9 of your study guide for your homework last night. First hour has worked on their study guide. The rest of the classes today will do this. 100 marbles are ready to drop in the Galton box. Where will most of the marbles land? The end slots or the middle slots? So as we go through the lesson today, I want you to think about this problem and where these might land. Has anybody seen something like this in a game show? How about The Price is Right? What is like this? The Plinko? The Plinko that they do on Price is Right? But where do those things usually land? So in the middle or on the ends? Today, we're going to talk about binomial distributions. And binomial means 2. So at each level of this Galton box, a marble can take one of 2 possible paths. So when you look at it, a ball comes in and it's not hitting a slot, it's hitting a peg. When it drops right in, it hits a peg. It is going to go either right or left because gravity is going to take hold of it, right? And going to push it down. So if it goes right or left, it's going to hit another peg and then it's going to bounce one of 2 ways. And eventually it's going to keep, each time it passes down, it's going to hit another peg and go left or right. Hit another peg, go left or right. Hit another peg and go left or right. So it can go one of 2 ways till it hits slots 1 through 9 at the bottom. So we could use binomial probabilities in situations involving 2 possible outcomes, such as this. A binomial experiment has these important features. It has a fixed number of trials. Each trial has 2 possible outcomes. The trials are independent, and the probability of each outcome is constant throughout the trials. So if you will look at your worksheet that you've ripped out and look at number 10 and answer that multiple choice question, and I'm going to get the door. All right, so let me get situated here and let's see. Number 10. So what's the answer to number 10? C. It says on multiple choice, and I think I've got it in here. Let's see. It's this one. And actually, let me move this up. It is so hot in here. All right. Yeah, here we go. Okay, so, and we're not turning it in yet. Come on. All right, so number 10 says, which of the following is not one of the conditions for a binomial experiment? There is a fixed number of trials. Well, let's look back. Yep, that's true. Each trial has two possible outcomes. That's true. The trials are dependent. The trials in the rules, it says the trials are independent. So that's your problem child, right? And then the last one is the probability of each outcome is constant throughout the trials, and that's it. So your answer is correct. That's C. So when the trials are dependent, or excuse me, when the trials are independent, that was the wrong answer, right? When the trials are independent, it means that if I run one test or experiment, it's not going to affect the outcome of the next experiment, right? So each one starts out fresh and has its own set of possibilities. So here's the formula. I blew this up and highlighted it in yellow so you can see it. This is the whole topic for today. The binomial probability, this is the formula right here, and you need to write this, and you need to write it on your whiteboards, and I'm going to have you write some things on your whiteboards. Suppose you have n repeated independent trials. So there's your n, the number of trials, right? Each with a probability of success, p. So p is your probability of success, lowercase p that is. And a probability of failure, which is q. So p are your successes, q are your failures. So when you add those percentages up, like 60% was of my experiments passed and 40% failed, well, 60 plus 40 equals, well, percent equals 1. 1 whole. So p plus q equals 1. Right? Your successes and failures equals the whole experiment, basically. So then the binomial probability of x successes in the n trials can be found by this formula. So there's lots of variables to remember here. So the p of x stands for binomial probability. And then notice this first thing right here. Anybody recognize this? NCX? Combinations. From our previous lessons. It sure is. So you remember how to do that in the calculator very quickly, right? So if I had 7C2, let's try to plug that in real quick in the calculator. So remember to clear everything out so you don't have anything goofy. All right. So you're going to go to probability. Well, first you're going to type 7 and then go to probability. And we're doing a C. So go down to 2, press enter. So it says 7 NCR. Now press the number 2 and enter. And you should get 21. Right? So that's an easy thing to clear out when you see the beginning of this. So we know that's now 21. All right? And then the rest, you just have to learn which term is which. And that's why I want you to write these on your whiteboards. All right, so let's move on. Oh, there it is again. I'm just going to stick that in the middle of the page here. So problem 1 says using a formula to find probabilities. As part of a promotion, a store is giving away scratch-off cards. Each card has a 40% chance of awarding a prize. Suppose you have 5 cards. Find the probability that exactly 4 of the 5 cards will reveal a prize. So what's our chances if that 4 of the 5 cards will have a prize? So let's learn how to create our variables here. So it says the situation has 5 repeated trials, 5 cards selected at random. Each trial has 2 possible outcomes. Either you're a winner or you're not. The probability of successes is constant at 0.4 throughout the trial. Right? 40% is 0.4. Remember that. Okay, and then the trials are independent. The outcome of scratching one card does not affect the probability of any of the other cards revealing a prize. So this is a binomial experiment because it's either a win or a lose. It has two outcomes. Okay, n is equal to 5, right? And let's see what was n again. N is the number of trials. So write that on your board. N equals number of trials. Actually, this is what I'd like for you to write. So x is your successes. N is your number of trials. P is your probability of success. And Q is your probability of failure. And remember that P plus Q equals 1. So remember, in this formula, you've got a capital P and you've got a lowercase p. In the capital P, that just means binomial probability of x successes. So that P, the capital P, is different from this P, which is your probability of successes. So NCX, there's your combination, times P to the x power times Q to the n minus x power. All right, so now let's go back to our problem here. So we know n is equal to 5. That's our number of trials because it says we're getting 5 cards. So that's what we want. That's how many times we're trying this experiment, 5 times. So n is equal to 5. X is equal to 4, and x is the number of successes. How many? It said, what's the probability that exactly 4 out of 5 will reveal a prize? So that's your successes. So that's your x. And we know that P, lowercase p, is a 40% chance. Each card has a 40% chance of getting a prize. So that's our probability of winning, 0.4. That means if you have a 40% chance of winning, that means you have a 60% chance of losing, right? Because 40 plus 60% is equal to 1. And if you don't see that, then you're just going to have to subtract 40 or 0.4. Well, let me do it this way. And you get 60%, right? Which is 0.6. Okay. So, that's everything you need. Our Q is equal to 0.6. So now, let's plug it in the formula. So we know, and here it is again, P of x is equal to NCX times P to the x power times Q to the n minus x power. So let's plug in our numbers. So P of, and we know x is equal to 4, so P of 4 is equal to, and actually I just went ahead and did it by hand, right, the NCX. So it was 5 factorial over 4 factorial times 5 minus 4 factorial. Right. So that comes out to 5 factorial over 4 factorial, which is just 5. Okay, so if you would have plugged that in, our n is 5. It would have been, let me get a different color, 5c, and then x is 4, 5c4. Plug it in and let's see. 5c4, enter, is 5. So you could have done that as well and just put in 5. Now, p to the x power, so we've got 0.4 to the 4th power. There that one is. Times q to the n minus x. Well, n minus x is 5 minus 4, which is 1. And q is 0.6, so it's 0.6 to the 1st power. Okay? So we end up with 5 times 0.4 to the fourth times 0.6. And let's plug that in. So 0.4 to the fourth power. I'm looking for my power. Remember, to do a power, you go 0.4 and the little rooftop sign to the fourth power. And it's 0.0256 times 0.6. And I'm just going to take that answer and multiply times 0.6, enter, and then take that times 5. And I get, oh, whoops, I didn't realize I'd worked this all out. There it is, 0.0768, which is about 8%, or 0.08. Okay? Any questions on that? That's all we do in this assignment. So what is the hardest part about this? Plucking out all your variables. And that's why I had you write them on the whiteboard. So let's do another one. Let's look at our first problem. On your workbook sheet, it says find the probability of X successes. So they're telling you to X successes in N trials for the given probability of success P on each trial. And I put the formula up here again, and actually they put it here again right there and worked most of your first problem for you. Okay, so they say X is equal to 5, N equal 8, P is 0.6. So then what's Q? If P is 0.6, what is Q? Do 1 minus 0.6. What do you get? 0.4. There you go. Remember, P plus Q equal 1. So there's everything. So now let's go. P of 5 is equal to 8C5. And when you plug in 8C5, you get 56 times 0.6 to the fifth power times 0.4 to the N minus X, which is 8 minus 5, the third power. So now the last thing is just calculations on the calculator. So it's equal to 0.28. Right, so your homework will be 1 through 7, and then turn it in. Okay? So I showed you here in this purple writing how to plug it in on the calculator. Remember that this little caret sign gives you, that turns it into a power. So that is 0.6 to the fifth power, and the next one is 0.4 to the third power. Right? Any questions over this? Yes.
I see how you get the first one, like, so you do, so to get Q, you do 0, you do 1 minus 0.6, and then that's 0.4, so then
That's your Q.
that's your Q.
Mm-hmm.
Okay, so then why in the third one, like in the third line, they didn't do N minus X, it was the 3, or they already saw that? These guys?
On number 3,
No, like on the first one, in the third, on the first problem, but the third line. Yeah.
right here.
Then instead of doing like N minus X, did they already solve that? Did they skip a step?
Okay, so let's look. What is N? N is 8. Yeah, they just didn't show this. And X is what? So it's 8 minus 5, and 8 minus 5 is 3. So they just didn't show the 8 minus 5. They didn't write that in. Okay, so does everybody see that? The question was, where did this subtraction go, the n minus x? Well, they didn't show that it was 8 minus 5, but they did show the results of that was 3. Okay? Any questions on this? Okay, I'm going to let you work number 2 together. So work number 2 together right now, and then we'll come back and check it. Are you finished with everything? The whole assignment? That fast? Dude, you're killing it. So rounded to decimal places. So that's going to be approximately equal to 0.16. Okay? Is there anybody who didn't get this? So 9C3 is 84. And then 0.5 cubed is 0.125. And then 0.5 to the 9 minus 3, which is 6. 0.5 to the 6th power is 0.015625. And then you multiply these together. And this is what you get. All right, so I want you to spend the rest of this class period working 3, 4, 5, 6, and 7. Let's pause and look at 7 real quick so we can set this up. Oh, yeah, we're not working it. I'm going to have time. Okay, it says, at a pet shop, 30% of the cats have short hair. The owner of the pet shop will randomly choose 6 cats to take to an animal show. What's the probability that 3 of the cats will have short hair? So you've got to learn how to pluck out what is what. So how many is he taking? That's your number of trials. He's taking 6 cats. So that's going to be n is equal to 6. Okay, what's the probability? So what do you want? 3 of the cats will have short hair. So that's your x, your successes. You want to know what is my x. It says 30% of the cats have short hair. So that's your success. They want to know what's the probability that 3 will have short hair. 30% has short hair, so that means that your lowercase p is equal to 0.3 or 30, right? That means that your q is what? 0.7 or 0.70. Think 30% plus 70% equals 100%. You're always just trying to get to 100%. That's why they say p plus q equals 1. All right? That's everything you need to know to solve that. Okay? So after you work these 7, then we're going to turn it in at the, well, we have 11 more minutes. Yes. Okay. Tell me what you wrote. For number 2, how did you start it? P of?
I did the 9C3 and then
Well, how did you start your problem? P of what equals? So what's your x? So you start the problem out. P of 3 equals, and I'm looking at this. So NCX. So what's it going to be? What's my NCX going to be? 9C3. Okay, times, and what's my P?
0.5.
So 0.5 to what power?
Third.
Times 0.5 to the n minus x, which is 9 minus 3 is 6. Okay, so now get your 9C3 in your calculator and tell me what it is. Is that where you're stuck? So type in the number 9 and then go to probability, the PRB button, and down arrow once to select NCR. Then press enter and then type 3 and enter. So it should look like this: 9 NCR 3, and then press enter and it's 84. Yes.
And after I got that, I didn't know what to do after.
Okay, so
Got the 0.5.
what is 0.5 to the third power? So go 0.5 and then the caret sign, 3, and enter. Do 0.5 caret sign, 3, enter. What is?
0.125.
Yes. And now do the same thing. Hit clear and hit 0.5 to the 6th power. Point 0.01525. Is that what you got?
Yeah.
Now that you've got that in your window, that last big number, now just hit multiply times, and it'll say answer times. So it's going to take the last answer, which was this guy, times, now type in 0.125, and then type in multiply again, times 84, and press enter.
That's 1.6240625.
And round that to 2 decimal places, and what do you get? is 4,
4.2.
no, 2 decimal places, 1, 2. So is 4 larger than 5 or smaller than 5? So then we just truncate this, so it's 0.16. See, that's 2 decimal places, 1, 2.
So what you got done is basically times 84. You times all three of those together.
Yes, because this is a multiplication problem. You're multiplying this times this times this. Do you see that? It's the same thing as saying I've got 5 times 3 times 2. Would you multiply those together? Would you agree that's a multiplication problem if you saw this? These are the same thing. They're just a little more complex. Okay, is everybody good on that? Okay, keep plugging away. Just remember to always get your Q. Just take 1 minus your P, and that gives you your Q. All right, and we'll take these up. If you're not finished at the end of the hour, I hope you will be, but if not, you can turn it in tomorrow first thing. And this concludes our lesson today. Thank you for watching.